Good evening, everyone. And there are still spots up front, so I see a lot of people coming in from other events right now, so come down, take some of these spots here because more people are probably going to be squeezing in afterwards. So welcome, everyone. I'm Fred Popowich. I'm a professor in the School of Computing Science at Simon Fraser University, where I'm also the director of the Professional Master's Program in Big Data. And together with my colleagues Peter Chow-White and Catherine Murray, we're leading this Colloquium series, the President's Dream Colloquium on Engaging Big Data, where we're taking a look at the questions like, what is big data? What can be done with it? And what should be done with it? So right now, we're into our 5th week of the Colloquium, and we're into our 3rd invited speaker of the Engaging Big Data series. And so that everyone knows, we are streaming and recording the session right here. And that's also the reason why, if you have questions afterwards, we have a mic set up there for you to ask those questions. I want to first start by thanking our sponsors, the Simon Fraser University President's Office. As you can tell, it's the President's Dream Colloquium, so the President gets mentioned first. We have the Office of Graduate Studies and Postdoctoral Fellows from SFU as supporters of it, the Faculty of Applied Science at Simon Fraser University, and the Faculty of Communication, Art, and Technology at Simon Fraser University. So we also have event sponsors for the different talks in this series, for the external talks. And our event sponsor for tonight is Simba Technologies, which is a Vancouver-based technology company with a long history of support for Simon Fraser University initiatives. They're a recognized world leader in terms of standards-based data access, and their analytics and connectivity solutions are used by a wide range of companies. You'll have to go to their website to see all the companies, but I can probably mention one of the companies that uses their stuff, and it's called Tableau, because we have somebody from that company here tonight. So also in the audience tonight, we have 20 students who are taking for credit this President's Dream Colloquium, students from a range of disciplines, so it gets people from across the university with different backgrounds working together. And they will be starting off the discussion after today's talk. And I'm now delighted to introduce you to Anne Giardini, who is the Chancellor of Simon Fraser University, for her to provide some welcoming remarks. Anne, over to you.
Thank you, Fred. And I'll start by acknowledging the Musqueam, Squamish, and Tsleil-Waututh First Nations on whose traditional and rather damp territories we're privileged to be gathering this evening. I'm delighted to be here for the 3rd lecture of the Spring 2016 President's Dream Colloquium on Engaging Big Data. SFU's Dream Colloquium was launched in 2012 to create a forum for interdisciplinary engagement amongst SFU students, faculty, and staff on themes of interest across the university. This year, the Dream Colloquium forms part of Simon Fraser University's 50th anniversary program, one of the many special events and initiatives highlighting 50 years of engagement. Students from diverse disciplines, many of you here, I hear, are enrolled for credit in the Colloquium, providing opportunities to learn not only from faculty members and guest speakers, but also, I hope, from each other. The Dream Colloquium comes highly recommended by its former students, who have described it as field school without having to leave the campus, an opportunity to explore topics that are relevant to my future career, and a great learning environment filled with eager students. Who could ask for more than that? This semester's class is fully subscribed, with students from all over the university, from English and archaeology to computing and business. They're exploring the exciting frontiers of big data, as well as all of the societal implications of a surveillance society. They'll be working on a big data project to engage the world through their research. I wish them the best in their exploration this spring. I'm looking forward to hearing a lot more about their projects. By fostering interdisciplinary dialogue, nurturing advanced research, and promoting a supportive learning environment, the Dream Colloquium reflects SFU's vision to be Canada's engaged university, defined by dynamic integration of innovative education, cutting-edge research, and far-reaching community engagement. We are thrilled with the community's response to this 7th Dream Colloquium on engaging big data. SFU is proud to be developing our global reputation for expertise in big data fields. In 2014, we launched the Professional Master's Program in Big Data, the first of its kind in Canada, to give students leading experiences with state-of-the-art data analysis. And we've just established the Joint Center on Big Data with Zhejiang University in Hangzhou, China. The center will provide a forum for faculty and students to advance big data science research in Canada and in China and connect research with industry applications. This Dream Colloquium is a wonderful opportunity to learn more about this field and to hear from some very exciting speakers. Of course, as we've heard, none of this would have been possible without the inspiration and dedication of faculty members who conceived of this and have worked hard to make it happen. Dr. Peter Chow White from the School of Communications, Faculty of Communications, Art and Technology. Dr. Catherine Murray, who I spoke with a few minutes ago, from the School of Communication, Faculty of Communications, Arts and Technology. And Dr. Fred Popovich, who you've heard from already, from the School of Computing Science. Thanks as well to Gladys Wee and the Graduate Studies Office for helping to organize this colloquium. This evening, we're honored to host Dr. Pat Hanrahan, who will speak on people, data, and analysis. I know that you, like me, look forward to hearing his many insights. You will have an opportunity to share your ideas and questions during a discussion period to follow. And with that, I will pass you on to Dr. Lynn Bartram, Associate Professor with the School of Interactive Arts and Technology, to introduce our guest speaker. Lynn.
Where is my? Did I take it? You did. So I will say that normally I don't need a cheat sheet, but unfortunately with Professor Hanrahan, he has so many accomplishments that I actually have something in front of me to remind me of everything. So it's my great honor to introduce Pat Hanrahan tonight. He is the Cannon Professor of Computer Science and Electrical Engineering at Stanford University, where he teaches computer graphics. His current research includes visualization, image synthesis, virtual worlds, and graphic systems and architecture. And before joining Stanford, he was at Pixar. In the many years in which he's been working in computer graphics, he's been a trailblazer and a world leader. He also worked at Pixar, where he developed RenderMan, which was the interface that allowed the programs that model complex scenes to describe them to the high-quality rendering engines that actually turned them into images, and is the basis of much of Pixar's truly amazing graphics, right? And in addition to Pixar, he's also founded two companies, Peakstream and Tableau Software, which has been one of the fastest-growing companies and software companies in the United States, and is a truly world-leading visualization platform. He also serves on the technical advisory boards of numerous software and hardware companies, including NVIDIA, Exaluna, Neoptica, VC, and Procedural. I can't even begin to remember all the awards that he's had, but just to give you an example, he has received 3 university teaching awards, 2 Academy Awards for Science and Technology, the Spirit of America Creativity Award, the SIGGRAPH Computer Graphics Award, Achievement Award, the SIGGRAPH Stephen A. Coons Award, and the IEEE Visualization Career Award. Most recently, he has been elected to both the National Academy of Engineering and the American Academy of Arts and Sciences. So without further ado, I'd like you to welcome Professor Hanrahan to the stage.
Thank you. Okay, can you hear me? Yes? Thank you, Lynn, for that great introduction. So it's really a pleasure to be here. I've been here about 5 years ago. I know a lot of people in Vancouver. I'm in graphics, so SIGGRAPH comes up here every other year for their annual conference, so I love to visit. And Today I'm just I decided this is a talk I've been thinking about for the last couple of years. It's a little bit of a different kind of talk. It's called People, Data, and Analysis. And it sort of tries to synthesize some research I've done at Stanford, as well as some practical experience I have founding Tableau and building the Tableau software. So let me just jump right into this. So when people are talking about data these days, they usually think about data scientists, or that's the thing that gets most of the press. And I think of the canonical examples of that. Probably the quants on Wall Street would be the ones I would think of. They sort of forged ahead many years ago, trying to predict the prices of stock, and some of those hedge funds like D.E. Shaw made an enormous amount of money by using quantitative techniques and lots of data analysis. But more recently, several years ago, there was the Netflix prize, and this was the team that won the prize, and they sort of looked like your typical data scientists, a couple nerds in there, a few mathematicians, and so on, and they were able to basically take the usage patterns of people and predict movie recommendations for them. So the basic idea of this was to try to recommend movies that people were more likely to buy, and of course that would help Netflix business quite a bit. And that got a lot of press, and because of the prize, it generated a lot of interest. So that would be a typical thing a data scientist might do. Another example where big data or data has been in the news a lot lately is Watson, the spectacular program that IBM wrote that actually beat Ken Jennings fairly convincingly at Jeopardy. And that I think is a pretty amazing achievement. I mean, to think that you could on the fly parse the natural language of the question, look up the answer, reason through it, and beat a human at that task. I mean, I certainly wouldn't have guessed that would have happened in my lifetime 5 or 10 years ago. And so this is an example of another application of data where they mined all the text on the web, Wikipedia and so on, and tried to build this predictive engine to make these kinds of answers. And one that's in the news a lot lately, you probably hear about it every day now, is convolutional neural networks. And this is a figure from the paper by Hinton in 2012, only a couple years ago. But they built this convolutional neural network, and there was this ImageNet collection of images which were classified by people, and they were able to train this convolutional neural network on these images classified by people and literally get performance that was almost 20 or 30% better than any other image recognition software that was ever built. And of course now, if you've been tracking this, there's like a news article every day about some different application of convolutional neural networks to speech and email spam filtering and so on. It's become quite a topic. In fact, right now some of the biggest data centers in the world are being built just to run these convolutional neural networks over various data. And so those are all examples of what people are talking about in data. But if you look at these examples, like recommendations or Jeopardy, or even this image classification, one thing that strikes out about them is there's not too many consequences if the program makes a mistake, right? If you make a recommendation and you don't like the recommendation, you just don't buy the film. Maybe you go watch a film you didn't like, but not too much damage is done. If Watson would have lost that Jeopardy, who cares? So there was no consequences of that. And even in this example of convolutional neural network, you're just trying to guess whether there's like a cat in the picture. And, if you guess that wrong, and you're only getting cats right about 70% of the time, but again, there's not too much consequences to that. So a lot of data analysis and big data being done by data scientists are making these predictions. But if you actually look at how the predictions are being used, although they may have impact on the businesses, dramatic impact on the businesses, they're not trying to make hard decisions. That's the way at least I've seen it. Now, here's another example where you might want to use data. This is from a few years ago when Hurricane Sandy was heading towards New Jersey, and Governor Christie had you decide whether he should evacuate New Jersey or not. and he was under a lot of pressure. And this is actually, I think it's a pretty cool visualization. This is the kind of data that he saw. They were making a bunch of measurements from the hurricane, wind velocity, position over time. And then they were running a bunch of predictive models. And each of these paths is a different model. So I found this pretty interesting. They have like 20 or so different models of how hurricanes move. And every one gives you a completely different prediction. In fact, only a couple of them even go towards New Jersey, right? So, you might look at this data and you might conclude, well, we don't have to evacuate New Jersey, okay, just ignore it, it's going to go away. But that would have been wrong, right? And, he was able to see, well, there's a fair number of chances that it could hit there. There's a reasonable chance it could hit there given all these predictions. And clearly these models aren't very good, right? Because they're all over the place. I mean, this one's heading off into the ocean. That one's hit Florida. It's already gone past Florida. I mean, so, he said, well, I better play it safe, right? There's too much at stake. I can't trust this analysis, and so I'm going to evacuate the coast, which turned out to be the right decision because the hurricane obviously hit the coast and did a tremendous amount of damage. So that's an example of using data where you have a decision to make where there's a lot of consequence. And notice that there was a person involved there, Governor Christie. Because, somebody had you make that call. You weren't going to just let the computer. Could you imagine? It just would have said, the computer would have just said, don't evacuate New Jersey. Right? That would not have been a good thing to do, right? And we don't think the computer would have made that decision correctly. So there's a lot of questions. What I'm trying to get at here is a lot of questions that we face where we want to use data analysis, but these simple predictive algorithms that data scientists are developing may not be sufficient to answer the question appropriately, particularly when the questions are serious, right? Like, should we leave our home? Or is this person a threat? Or should I undergo chemotherapy? In fact, it's sort of interesting. IBM thinks the best application of Watson is actually in health. They want to help doctors make predictions. But from what I can tell, it's having quite a bit of trouble getting any traction there. And you can sort of imagine why. Because would you want Watson to tell you to take chemotherapy or not? And then you'd ask it, if you ask Watson, well, why should I do it? And what would it say to you? It said, I predicted it, right? I think you should take this drug. But it won't be able to tell you much about your life history or case or any of that stuff. So there are lots of serious questions that we face that we want to use data. And I think we need to have people involved in making these decisions. Now, you could say, I don't want to be too much. I mean, by the way, I want to make it clear. I love all those advances in artificial intelligence, and I think they're really cool. But you just have to temper your enthusiasm with the reality of it. And a lot of data, you can ask, well, why isn't the computer able to make the right decision? If it was to work all by itself, why would it not be able to make the right decision? Well, we all know data is often incomplete, right? If you don't measure anything, you're not going to have any of that data inside the computer. How could it possibly be considering things you didn't measure? And there are lots of things we don't measure. In fact, we very selectively measure things. Data often has errors. If you've ever collected data, I actually run my own weather station at home. I can just tell you, my weather station is constantly crashing. The temperature is wrong. I can't automatically correct all the errors. And maybe we can get better at it, but it will often have errors in it. And data is biased, right? We collect information about some people in some ways, and so on. So all these things mean that the computer basically doesn't have all the information in its memory that we collectively as a society have about the decision or the problem what we're trying to solve. So that's just a very real thing. It would be neat if computers could monitor everything about the world. I mean, maybe that would be neat. I don't know, it might be a little scary. But if they could monitor everything about the world, or as much as we know about the world, it might change, but we're not even close to that right now. And then the second big reason I think you need people, of course, is that often these decisions require ethical judgment, or I might say also personal preference, like if you want to take a certain drug or not, you have religious issues and so on. And so again, you're not going to hand over all these decisions to the computers. Now, I think this is all sort of obvious, but if you read the press these days, it seems like everything is going to be automated and computers are just going to sort of, just start making more and more decisions for us. And I think we have to be very careful about that. Okay, so I'm trying to make the case we need the people to be involved in analysis. I don't think this is that hard of a case to make, but it just doesn't get much press. So how do we think about that? Well, the first thing is, what kinds of people do analysis? What's the problem what's the problems that they have? I'm in the School of Engineering at Stanford, and we had a faculty meeting a few weeks ago, and our dean, Persis Drell, remarkable woman, she ran the Stanford Linear Accelerator. But she was just sort of, we're having this problem where we have huge enrollments in computer science, and basically computer science is taking over the university. So that's not, it doesn't bother me that much, but it's bothering a lot of people. Okay. So what she wants to know is what are the most, and even more generally, engineering is taking over the university. We expect to have, Stanford will have 50% of its students be engineers within a year or two. So what are the most popular courses outside the School of Engineering taken by School of Engineering students, right? And you can imagine a dean might want to know that, right? Because maybe she wants to make sure, or she just wants to know, what interests do the School of Engineering programs have? How do they become well-rounded? Maybe we should work with those departments if they're doing a good job, or even if they're not doing a good job, maybe we should figure out a way to make their courses more appealing to our students. That's a typical kind of question that somebody has like her, and she couldn't answer it. She had no way of getting it. Now, that's a little surprising, right? Because, it's clear everybody's registering for these courses, and that data is somewhere, right? But she can't answer that question, okay? Simple question, she can't answer it. And one of the great things about Tableau is I just talk to all these people that do analysis every day, and I can just tell you stories. But this doctor was from Seattle Children's Hospital, a surgeon there, and they're asking questions like, why are my surgery patients returning to the hospital? So they all get a little data dump every day, and they did these surgeries over the last few weeks, and they see which ones are getting returned, or which ones come back for further treatment. And they're very serious about trying to improve their surgeries to lead to better outcomes. Teachers, right? This is from the Spokane School District, which is actually, for a while, was one of the most underachieving school districts in the United States. Teachers there are just really wondering what's causing their students to drop out. They were having huge problems with dropouts. And why is a student missing class and not turning in their homework? So these are typical kinds of questions you see, okay? In business, it even gets more extreme, right? Doll collector, this comes from eBay. I don't know if you know how eBay works, but they have all these categories, like dolls and stamps and guns and so on. And they have what they call category managers. And there's somebody in charge of dolls. And they're experts on dolls. And so they monitor the doll market, right? And so, suddenly what happens is these Barbie dolls are going, their prices are going like crazy, and they're going through the roof. What's causing that, right? Is there some fraud going on? What's going on here? They want to know the answer to that. Because, if they don't correct it, they're responsible for making sure their marketplace is being used properly. If there was a stamp market, okay, there'd be completely different questions, and the way you would answer the question, or even what question you would pose about stamps, would be completely different, right? If you know a lot about dolls, you might not know anything about stamps, right? Right? So they have all these experts, right? Each one is an expert in stamps or dolls or whatever. They're not computer scientists. They're just experts in their domain. But they need to use their data to answer their questions. This final example, I just want to give you a little flavor for this because it's just really interesting. So this is from Zynga. Probably recognize the screenshot. But, their whole thing, and they pretty much revolutionized the game industry. They haven't been doing that well recently, but, they basically they did data-driven games. And so what they did is they tried to monitor the gameplay, both to make the games more fun to play, and in their case, they got revenue by having people buy virtual objects of types, virtual goods. And so, they wanted to know what causes players to buy virtual goods. And this kind of question was being asked by somebody that designed the game producer And so they would ask this question. So this is sort of interesting, right? So this, if you go out into the real world, you could just sort of ask is like, how many questions do we want to ask a day? Like or if you're a company, how many questions could you ask? Like a dean had one question, and they couldn't even get it answered, right? Like, so how many of these can you ask? And you'd like to have data here, right? Because these things are probably things that the data would tell you something about the answer to. So there are a lot of these people. Hey, throwing a few Tableau things, but we just had our customer conference in the MGM Grand Auditorium, and there were 10,000 of these kinds of people in this conference, which is pretty remarkable. Now, I call these people data enthusiasts. Now, why do I call them data enthusiasts? First of all, they really are into analyzing data. I mean, they are super, super into it. Why are they into it? Well, I think they're into it for a variety of reasons. One is they really care about the answers to the questions. They're on a mission. That doctor, right? That doctor really wants to treat his patients well, right? And if they answer that question, they get great personal satisfaction out of treating their patients well and doing the analysis that led to the better treatment, as would be the case with this teacher or anybody, even in a company. If you do your job well and you solve some big problem in your company, you're sort of a hero, right? So they are super dedicated to the mission of their company or their institution. The second thing I think that makes them so enthusiastic is that they seem somewhat persecuted, right? Because like if you're a nerd or a data person, you're probably not the average person. Like if you're in the United States watching the election, if you were into the data of the election, you were not the average person, right? The average person was just listening to all the insults flying around on Twitter. They didn't care whether facts were being used anywhere. So these people that want to use data and use facts are in the minority. They think, not only am I trying to solve this problem, but nobody cares about me, And when they get together and find out there are other people like themselves, they go crazy. It's just pretty remarkable, okay? So there are a lot of these data enthusiasts, and I sort of think of these people as typical, ordinary, we might have called them knowledge workers some number of years ago, but they're people that, have basic computer literacy skills, plus they're experts in their domain. They don't know statistics. They don't know how to program Hadoop jobs. They probably don't even know how to program. They don't know how to do SQL, right? They're doctors and teachers and deans and things like that. But they're all using data, okay, to answer these questions. And there's probably like as many of them out there or more as there are Excel users, which is in the hundreds of millions. When people talk about data scientists, they talk about like 10,000 of them or something like that. So that's the kind of people we're talking about. Now, what do they do? Actually, it's mostly what I've been thinking about over the years is analytical thinking. Actually, partly because I'm a teacher. I mean, I think my job at Stanford is to teach students to think. I mean, that's if you ask me like, what's my number one high-level mission statement, right? I teach them to think about things in various ways. I give them tools for thinking. And particularly, since I'm more scientific and quantitative, I think of analytical thinking, right? And I'll tell you a little bit. Well, so what's that? It's very interesting. Like I ask other faculty members, like, what's analytical thinking? Or I ask students, like, where did you learn how to think analytically? And most people don't know what it is, or they don't know. I mean, they sort of have a vague notion, but they never took a course in it, and it's sort of interesting. And I also noticed that lots of times they actually give tests where they test your analytical thinking skills, and a lot of science and engineering students actually do really poorly at analytical thinking on these tests. It's sort of interesting. Actually, I think it's sort of interesting to be a good analytical thinker. So what's the key to being a good analytical thinker? Okay, being Sherlock Holmes. That's what I think the key is, right? You're a detective, right? You have some problem, like you're on that question, like, who killed so-and-so, right? You're gonna go solve that crime, right? You want to answer some question like, why are my patients coming back from surgery, right? You got to go collect all the clues up, and you got to like reason, and so on. And so a lot of times they're sort of detective-like, okay? My doctor is very detective-like, okay? Like if I have any problems, she doesn't just say, oh, Pat, you're imagining all that, just go home, don't worry about it. Or she doesn't just say, oh, by the way, I just got this drug company gave me this drug, why don't you try it? She starts running a bunch of tests and says, well, let's look into this. Like, it could be this or that, and so on. She's like a detective. She wants to find what's wrong with me, So she's a good analytical thinker. And, I like Sherlock Holmes. Hopefully, a lot of people are Sherlock Holmes fans here. But if you read his books, they're like great if you want to be a data analysis, right? Like, here are two of my favorite quotes, right? It is a capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit theories instead of theories to suit facts, right? Sort of basic analytical thinking. Right? I'd like to tell my students that. That's a good thing. Okay, and then, this I like too. Data, data, data. I can't make bricks without clay. Anybody remember that one? Great quote, right? He's in a world, right? He has a magnifying glass, right? He has a magnifying glass. He has to walk around with his magnifying glass finding data, right? I always think just like, I bet he'd really be happy today. Like he could throw away his magnifying glass, all the data would just sort of like fall on him from all directions, and he could just sort of sort it out. But he really had to like put unbelievable effort into finding the relevant data to solve his problems. I think that's actually most of it. It's a mindset. It's a mindset of trying to figure something out by assembling clues and then reasoning them step by step, right? So this is the definition I've been using in when I've been teaching it. There's other people that have similar definitions, but I like this one because each of the 4 lines means something to me. It's a structured approach to answering questions and making decisions based on facts and data. Again, I feel sort of embarrassed to explain stuff like this, but, most people seem to have forgotten some of these things. So anyway, let's go through it. Structured approach. It's not a random search. Sherlock Holmes just doesn't hop on a bus somewhere and go some other part of town and see if there's something under the light post there. He has hypotheses, and he's trying to, he has a methodology, right? Like you have to have a methodology. When I was in school, we had to learn these methodologies, right? He answered questions, right? Like he wasn't just hoping he would find out the answer. He had well-defined things he was looking for. In science, we'd call that a hypothesis, right? We have we have something that we could answer. If we have a question, we could answer. In fact, a lot of science is about asking the right questions that are answerable, right? Making decisions. I like that one in there because that has to do with my first point, which is it depends on the decision you're making what the analysis is. So if it's a really, life-threatening decision versus like a game recommendation, you might use completely different analysis. If you want to get people to stop selling cigarettes in the United States, you've got to do a lot different analysis, right, than if you want to do a movie recommendation. Okay, and then based on facts on data. So these lines are all pretty important, and you have to learn about each of these to do this well. So one thing I've done with Tableau, we just make everybody analyze data every day. It's really just analyze it. Ask questions, figure out what's going on, analyze it. So now, I just grabbed this other quote from Hal Varian. He's the guy that, he'd be a good person to have come up to me. He's a data scientist. This is the sexiest job of the 21st century. Yeah, that's the quote that gets all the press. Here's what he really said. He said, the ability to take data, to be able to understand it, to process it, to extract value from it, to visualize it, to communicate it, is going to be a hugely important skill in the next decades. Not only at the professional level, but even at the educational level for elementary school kids, for high school kids, college kids. Because we essentially have free and ubiquitous data. And then he goes on here and he says, most people learn data analysis, or they think they do it, through statistics. Like at Stanford, If you say, I want to study data analysis, they send you over to the statistics department. You take a statistics course. But that's just part of it, right? And he starts listing out all these other aspects of it. And this, I think, is sort of what drives me. Whoops. So this sort of mission statement, in some sense, drives me, is how do we get, imagine in 5 years or 10 years where everybody is just manipulating data every day. Right? Maybe you could argue we all are already doing it, but at some point we'll all be doing it constantly. And what do we need to do to make that work? And so the first thing you have to do is sort of figure out like what is involved in doing analysis. So I'm trying to put together a course that I could teach to like freshmen and sophomores on data analysis. And I'm not going to go through all these things, but these are like each week in some sense. Like how to ask questions, how to find data, how to verify data, how to clean it up and normalize it, how to join it with other data, how to explore relationships, how to summarize data, how to confirm hypotheses and analyze it. This is the statistics part. How to communicate the findings with others and how to decide and act. These are the kinds of questions and things you need to learn about in order to do this. So I know and I always like this quote too, is data analysis is like doing experiments. Now, I like that because I was a physicist and I learned data analysis by doing experiments. I actually, when I went to school, my first job was to do data analysis. That's the University of Wisconsin, not University of Washington. But this is a lab I worked in. And it was pretty tedious, actually. I'd get these big printouts like this of all these numbers, and I'd have to plot them by hand. And that's actually the book. I still have that book, Data Reduction, Error Analysis for Physical Sciences. But I'm telling you this is like I think I'm a scientist, and I've learned one of the things I've learned is how to think quantitatively and do analytical thinking. It's one of the things probably I learned in school that was most valuable. And I understand it well. And part of when I'm thinking about data and people, I want them to become better analysts. I want them to think analytically better about problems. That's what drives me, is I want them to have all these tools at their disposal that I learned about when I was in school. Okay, so that's the preamble. Just to summarize very quickly, is any time you're building technology, you have to understand the people you're building it for, and you have to understand what they do. It's the number one question. It's sort of obvious, but you have to feel it. Like I can tell you stories about doctors and educators and stuff, and what I live their lives. I can immerse myself in their daily experiences. And over the last 10 years of Tableau, I've even gotten more into it. I just know how they think. I can go have a beer with them and hang out with them, and we get along great, okay? And then I know what they do, because I did it. I learned it. I learned it in school. I know what analysis is all about, okay? And if you're building software, you got to be able to answer those two questions. Who are you building it for, and what do they need your help for? What are you helping them do? So I know I'm maybe belaboring this, but this is like basic, people-oriented design, if you like. Okay, so let me see. I'm probably going out on that more general stuff. But now I just want to sort of end with reading the last, I don't know how much, hopefully I have like 15, 20 minutes. It's just a little bit about like, when I went to Stanford, I got super interested in trying to do data analysis and visualization. And what I'm telling you sort of is really what was in the background of my head, before I just decided I wanted to work on it. But then I had to actually do something about it. And it was a great time. This was, a while ago. But let me just tell you a little bit about how I approach this problem, and I'll call this the design of Tableau. Like, what are various things that we designed about it that tried to solve this problem? So the first thing I did is I asked the smartest person I knew, how do people do analysis now? Okay, Jim Gray is a super smart guy. He won the Turing Award. The smartest guy I knew in say, data, at least, databases. And he said, he instantly came back. Oh yeah, people use Excel. Right? And by the way, this is still true. This is just as true now as it was back then. They use Excel, right? 99% of all data analysis in the world is done with Excel. The rest is in the noise. Okay? And, I said, okay, well, yeah. And by the way, this is data in Excel. Excel wasn't even designed to analyze data, right? That's not like a accounting table or a financial statement. That's just a bunch of columns of numbers. It just happened to be a table so you could stuff data in it. Spreadsheets weren't designed to be tables of numbers. But anyway, so then people started adding stuff to Excel to help make it that. And this is what he told me was, well, the next thing they do is they use these things called pivot tables or crosstabs, where they roll up the data. So they drag various columns and stuff, various attributes to these rows and columns, and then sum the data up in all the cells. Probably everybody's done this a little bit. Although not a lot of people do pivot tables. But this, if you were to go out in like what they would call business intelligence, this would be the standard business intelligence tool would be this, like, they call this slicing and dicing, right? That's what they do all day. Slice and dice data, often in Excel, but they have other tools as well. So that's one of the tricks I do. Is I just ask some smart person some totally naive question, what do people do? And then you say, well, can you make it better, right? Could you make this better? So I was into graphics, and I had a new student coming in, SFU graduate, by the way. Totally amazing guy. Should be very proud of him. He was one smart guy. He was my grad student, and actually Tamara was a grad student. She's in the audience here at the time. We were working on a bunch of data analysis problems, and one day we just said, let's say we could do visual pivot tables, right? And so actually, I'll just give you a demo. This is almost exactly the same demo. Actually, I asked him. So here, let me see. I asked him. We had this idea. It's sort of like completely. I'm telling you this because it was a completely trivial idea. Like we had these Excel files and we had these pivot tables. What if we could just make them visual? And I asked him. I said, I seem to remember you did that in like one day. Like this was a couple months ago. I said, how long? It seemed like you just did it the next day. Like go into your grad students, you brainstorm with them for a while. And it's either a totally dud idea, nothing ever happens, or they do it in a day or two. Well, it turns out he did it. He said, oh, no, I think I spent a whole week on that. Okay, but anyways, he did something like this, where if you take this sales thing, drag it into here, and you take this market thing, drag it into here. This is just this is a database of product sales. Now you had this crosstab, right? This is what they call a crosstab, pivot table, crosstab. Okay, so then we said, well, what say you could just take this thing and drag it up to here, and because it was a quantitative value, it would make a bar chart. That's the whole idea. And if you drag multiple quantitative axes on there, you'd make maybe a scatter plot or a map. If it was a geographic. But the key thing is what it did is it made it really easy for an Excel user to suddenly use visualization, and it had all the power of Excel in some sense, right? And then at the same time, I remember going to talk to a lot of other people. I'd go talk to the experts in visualization, and they would tell me, "Oh, Excel is holding us back." They would say, "No, this Excel thing is terrible. We got to kill it. It's holding us back." And I'm supposed to say, "Well, why do people use it?" Well, it was obvious why they used it. It had all this analytical capability in there. It could do calculations and access databases and so on. If you just put a visualization tool there without any analytical capability, the ability to access data, what good is that going to be? So, you couldn't you had to realize why they were using it, right? So anyway, that was pretty much the idea. That was his idea. So, amazingly, you can get a PhD thesis for that. I actually had part of the idea too. But he's a brilliant guy. He did it way beyond anything I could have ever done. But anyway, this was actually his original prototype. Notice the nice blue color scheme. crafty SGI graphics, if you remember that. Stuff like that. Anyway, it looks almost exactly the same. It's been refined a fair amount, but it's the basic idea is there. Okay, so all right. So now, what are some things so that was the simple idea, but like how do you make that into something really useful? So there were three, I'm just going to talk about three sort of things that we thought about a lot. One is like, what visualizations should you include? What visualization should you include? Like at the time, everybody was building all these goofy visualizations like tree maps and stuff like that. So the first thing you might do is like, well, we're going to add all these visualizations like tree maps into it. But we sort of didn't do that. And just let me give you the example. So this is where I benefited from a cognitive psychologist at Stanford, Barbara Tversky, and I did a bunch of reading about this. But it was about effectiveness of representations. That was an interesting thing because I thought of them as visualizations and they called them representations. So I did like translate, But anyway, so psychologists think we have these symbolic representations. But anyway, this is a simple example. Is if you have a table like this and you say how much mint tea was sold in the West, this table is actually considered a fairly good visualization if you want to answer that question. So given a question and a task, this is pretty good. Why is it good? Because you're looking something up, right? How much mint tea was sold in the West? And the table actually has all these little clever things that help you look it up. For example, Central, East, South, and West are in alphabetical order. That's useful, right? You can do binary search if you know that, right? And then those tables have hierarchical headers. Well, that's useful, right? Hierarchy, binary search again. So you can very quickly home in on the value you want in less than linear time. I'm talking about computer science. Right? Linear time would mean you'd look at all the elements in the table and look it up. That'd be a really bad algorithm, right? This table supports these really clever, indexes. So this table is like an awesome visualization. Tables are visualizations. Now, if you just change the question a little bit, is what product in what region sold the most? Now you're looking for the number that's the largest. Those headers don't help you at all, right? They don't help you one bit. Anybody found it? It takes worse than linear time because, as you're scanning around, you have to be doing these subtractions in your head. And then you also have to remember the current max. And if you, for some reason, screw up a subtraction or miss the current max, you got to start over again. And if this was a giant table, right, it would just take forever. Anybody find it? What? Okay. Here's the same thing. Right. But this is trivial, right? It takes constant time. So, algorithm guy, constant time algorithm. Wow, awesome. So, but these are the building blocks of visualizations and representations. Is you build the ones that work the best for the problem you're trying to solve. This is like a trivial example, but when I started Tableau, I'd go in place and people would say, "Well, I don't think visualization is useful." Where did you ever come up? Is this useful to be able to look this up immediately? That's clearly useful, right? Why are we talking about this? So anyway, so it's just a simple thing. But anyway, but the key is you need lots of representations. There's no one magic representation. You need lots of representations, and given the question and the point you're trying to make, you want to use a different representation. So in the case of Tableau, we wanted to build up all the common representations. We also we wanted to we thought maybe another thing I learned from Barbara was actually people think it's really easy to read visualizations and get the information in your brain. It's actually very hard. So simple ones work much better than complicated ones. So we went for the ones that people might already know, like maps and tables. I mentioned this table thing because it's sort of a joke for me. They would claim tables are not visualizations. If you see it, it's a visualization, right? It's a visualization. So, these are all visualizations that are useful. And what we did is we made a language for visualization. So what we did is we took all these things I was dragging around onto those things we called shelves, and we came up with this little language thing, which let us express. What's nice about languages is they're compositional, they're generative, right? You can if you have English, you can say lots of things in lots of different ways. So this language let us make lots of different visualizations in different ways. So we didn't care about, we didn't know what the right visualization was. We wanted the user to learn what the right one. So that actually is a pretty big thing. Most visualization systems come in with a bunch of canned visualizations that don't work very well for the problem they're trying to solve. That's turned out to be a big thing. The second thing, was even trickier, is you had this Excel thing in the background, which was doing all these calculations and accessing the database. How do you couple up the visualization with the data and analysis? How do you make all that work? Because if you can't calculate anything, you're not going to be able to do analysis. Like when I did that pivot table, I was doing all those summations and slicing and dicing and filtering and stuff. So, and moreover, let's say you wanted to make it interactive. How could you make interactive calculations easy to do? So the first thing was if you looked at this example I gave here, this looks a lot like SQL, right? If you know SQL, may not everybody does, but this is typically the way databases are queried in the language sort of like this. So, and I purposely wrote this like this because it's pretty suggestive that if you just tweak this a little bit, you could start putting calculations in here, like sum of amount on size, and so on. So by doing these calculations in the same language, then you could do both calculations as well as visualization. So we call this VizQL, Visual Query Language. But it's even more complicated than that. And I never wrote a paper about this, but the complicated thing is, let's say somebody's dragging things around onto all those shelves. What kinds of calculations can they do by doing drag and drop? Right? Because, they're not typing in this language. What kind of calculations can they do by drag and drop? That's not as obvious. But, I remember when I was in grad school, this crazy guy came to give a talk called Zoof. Probably was in the 70s. I'm older than you think. But anyway, this shows you how old it is. This is like the paper they used. That's the fonts they had back then, okay? Anyway, he was a database guy, one of the pioneers of databases. And here he had some example where you had a database with departments where you had various items for sale. Like you had, household department selling pens. And then you had a supplier thing where you had various companies that would supply you those pens. And all you wanted to do, answer some question. Actually, I got a lot out of these database guys. By the way, they always have questions. I like that. Let's answer a specific question, right? Find the departments that sells an item supplied by, I like that. I like questions. Okay, so anyways, but then he showed, and I'm not going to go through this in detail because it's pretty weird, but he showed that by dragging various fields into a table, you could, the way he said, suppose you could drag the fields into the table to define the table that was the query that you wanted to see. In other words, he said you could drag the fields into the table, and then the table that got created would be the answer to the queries. Okay, so here he's dragging these things together into this table, and he gets this thing. This is a little fast. But then he went on to prove, which was like totally awesome, that any relational query can be formed by this drag and drop technique. That's cool. Oh, I'm a computer scientist. That is cool. Okay, that means you're not limited by having this interactive drag and drop interface. You can do anything you want. And I say that that's a big thing because normally when you have a system like this, you're doing a bunch of visualization stuff. Let's say you're using like Adobe Illustrator or anything, any graphics system or even visualization. You just do all the graphics, but if you want to do any other stuff, you got to drop out of that system, go do it in another system, and then bring it back in because you can't do those complicated calculations and stuff. And usually all systems, there will be some limit. Now, the limit here is you have to do relational queries. There are other kinds of queries you might want to do that can't be done in this way. But So that we leveraged that idea in Tableau so that we would have an analytical richness where you could do any query that you would hope to be able to do. So that was cool. That was an important idea. Okay, the third one, and then I'm going to be finished, is, okay, analysts are not trained in graphic design. Now, this hurt me a lot, right? I like graphic design. I like it. It's like everybody should learn graphic design. Just go take a drawing course and, whatever. Everybody should know graphic design. But think about it. This is true, right? That doctor does not know a lot about graphic. They might know something about it, but my dean, I can guarantee you, doesn't know anything about graphic design based on what I've seen. Okay, so but that doesn't mean they're not good deans and they don't have questions, but they don't know much about graphic design. Now, this is problematic if you're a graphics person, right? As I said. And not only that, it takes great discipline to not make the program be a graphic design program, right? Because I like graphics. I want to make them make great graphics. That's what motivates me. That's what I want to make. I'm going to make a tool that lets them make great graphics like I can make, right? But they don't know anything about it. So you're in trouble there. So that was probably one of the trickiest things, and sort of something we didn't think. And more generally, people just were not. I'd say even beyond that, they didn't really even know how to think visually. Sometimes, they didn't even know what would be a good representation for the data. They might not even know that. So we spent a lot of time trying to sort of automate graphics. Now you should say, oh, but Pat was telling us how bad automation is. Automation, blah, blah, blah. That's never going to work. But we came up with some tricks. So first of all, the first trick, which actually I think I was here like 10 years ago, and I actually talked a little bit about this guy, Jacques Bertrand. But he worked out this little clever system, which was the starting point of what we did. Which and this is just neat because, I don't know, I'm telling stories now, but actually, this book, The Semiology of Graphics, I'll tell you one story, tangent. That book was published by the University of Wisconsin Press. And I was in, Madison, where I went to school, go to some used bookstore, and I find this book when I was in, an undergrad. I don't even know what semiology is. I've never heard of it. Whatever. But I started opening this book, and I was like, this is fascinating. Someday I'm going to read this book. Okay, I bought it. Okay? Anyways, anyways, semiology, go study it. It's cool. Anyway, I'm not going to go into details, but what he did is he sort of said, he had this table, which is in his book. He said that there could be different types of variables, and you might want to represent certain information visually for certain types of variables and not for other types of variables. So some rules of thumb. And where the letters are big, it says you can represent nominal, ordinal, or quantitative. Nominal just means categories. Ordered means days of the week. Quantitative means a number. You can use that in position. It works great. But if you try to represent quantitative things with a value, which is a brightness, it doesn't work very well, and so on. And notice there's lots of bad things in here. But anyway, it's a lot more complicated than this. But we also worked with a guy named Jack McKinley who did a lot of research on this, and we were able to automate a lot of rules, okay, about graphic design. So I want to get into the questions here, but let me just tell you this automation of graphic rules was one of the trickiest things I've ever worked on. Okay, so let me just tell you some principles now you can argue with these principles, but this is what we use to help crack some of these problems. One is, whenever possible, use semantics, not statistics. So if you know the type of the data and what it means, you can do a lot more about what the right graphic is, okay, than just having some statistical or other simple property. So for example, if you know it's time, you want to make a timeline. If you know it's space, you want to make a map. Et cetera, et cetera. It just goes on and on. But the more semantics you have, and then, by the way, if you know about time, we know about fiscal years, we know about months, we know about calendars, and all that kind of stuff. So, and that all percolates up into the visual design, is that we have the visual representations we choose are often very semantically enriched. And that's also sort of, I still think this is sort of an open problem in visualization, is how to add more semantics into our visualizations, because we tend to be more like statistical graphics, which have minimal semantics. The second trick here was, whenever you have an automated system, just have it make a default, not actually do it. Or let you override it, I should say. It's a very simple thing. And we would sweat over this, all the graphic designers are going to hate our system because we're going to choose some color that they don't like, right? Or they're going to, but no, they just change it. And if as long as, they're happy to change it, and that's what they expect to do, but if they don't have to change it, then you just save them some work. And why would you complain about that? And the lack of rigid rules, I should say, I didn't add changing here. The lack of rigid rules, and there's a lot of debate in visualization, which I don't really enjoy myself, about rigid rules, but I don't like rigid rules, okay? So I think people should be able to break the rules. Whatever. We can talk about, ask me a question about that. I like to break the rules. Okay, so, but there are rules. You might want to abide by them, but they're not rigid rules. You can break the rules. It's okay to break the rules sometimes. Okay, the third thing, which is the trickiest one, is you're trying to automate all this stuff, all this graphic design, and you have to figure out if you know enough to do it right or wrong. So, for example, the system, I call this meta-automation. And I think this is actually a sort of a frontier right now given all the AI and big data stuff, is does the system know what it's doing? Watson actually is pretty good. Watson was actually sort of a breakthrough because it knew whether it should push the buzzer and try to answer the question. It knew that whether it knew the answer or not. It's pretty cool, right? Or at least if it didn't do that, it wouldn't do as well. It's a game, right? You only bet if you think you're going to win, right? So, but anyways, so we have this meta automation in there. So if we know it's good to do this, we do it. Okay? If we know it's bad to do this, we don't do it. Okay? That's pretty obvious, right? But it can be very subtle there, right? If you drag something onto onto color, we know that color is only good if you have a small number of things. So if you drag something on with 4 things, just do it. Assign the colors automatically. You're in good shape. If you drag something with 10,000 items in it onto color, now you're going to have 10,000 different colors. We know that we can't distinguish 10,000 different colors, so we don't do it. Right? Simple. Okay, that's good. Now, the more interesting case is it could be good or it could be bad. Right? That's like the little paper clip, right? It's sort of giving you some useful information. Okay? Our principle is don't do it. Because, and this is sort of subtle, because if you do it wrong, they're going to be annoyed at you. Right? It creates magic. If you think you have to do everything manually, and if it periodically saves you a lot of time and effort, you think the system is amazing. Because otherwise you have to do it all manually. But since you think you have to do it all manually, if it doesn't do it automatically, you just think it's normal. But if it screws it up and you have to go undo all the things it did, then you're in big trouble. So anyway, that's sort of interesting. So I think this kind of thing is going to come up quite a bit, is whether, when you're doing these automation and stuff like this, does it know whether it's able to, is the system that's doing the automation able to tell what it's doing? Is it good or bad? And second, what happens? How does it handle these intermediate cases? Is a very tricky issue. So that's interesting. I think that's interesting. Okay, so I think I'm out of time. Okay, so I just wanted to show you some of those things because I think, to me, a lot of this stuff, at least in visualization, is sort of about design but I'll call it deep design because it's not just designing the user interface and the visualization, it's about designing the whole system, top to bottom. So just to summarize, I think a lot of us need to talk a lot more about how to use data intelligently and responsibly. I got trained in that too because I was a scientist. A lot of people now seem to be ignoring a lot of those things. You have to understand, if you're building tools, you have to understand the people that use your tools. In our case, their analysis. I invented this persona, which I call the detective or the data enthusiast. You notice I have very specific, vivid names for these people because I want something that I can use to guide my judgment. But then I say, these people that I'm looking at, they have deep domain knowledge, like a doctor or a surgeon, with very well-defined and intelligent questions, right? Because they're experts in their domain, on a mission, right? They care that they do a good job. They're not programmers, they're not statisticians, they're not visual designers. Okay, what do they do? Well, I come to my course in next year or 2 years. Analysis is a structured process. I don't quite know exactly what they do, but I wish I knew what they did and what analysis was. I've read every book I can. I still don't have a great definition, but I'm still searching and I'm finding it, and I believe there's some core set of methodologies that we can use in analysis, and that's when we build these tools, that's what we want to help people do. And we just need to understand that better and then build tools that deal with it. And also, it has to deal with all of it. So I gave you all those various things. If you take like a Tableau, we only do like 2 of those things. So there's a lot of wide open space in there. And then I'll just say, to me, I consider this sort of a positive thing. I'm actually not that interested in big data. I'm just interested in like ubiquitous data everywhere. And we'll have more and more access to data. Sherlock Holmes would be really happy. Throw away his magnifying glass. Just get the data. But the good thing is that I hope, because I was a scientist, that more decisions, if appropriate, should be based on facts and data. That, I think, is a pretty exciting prospect. So thank you very much.
Pat, thank you very much for a really, really interesting talk and provocative, and especially the stories, right? It's the stories of your experiences that are really helpful for us in understanding some of these issues and moving forward with them. So now we have question and answer period. For those who don't know who you are, my name is Peter Chow White. I'm one of the co-organizers, co-collaborators, co-conspirators, depends on what day it is for us putting this course together. But glad to see so many people here tonight. We have some questions. There's a microphone in the back, or halfway through, so if you want to make your way to the mic, then we can take questions. I'll be moderating. To start, though, we have 3 of our fantastic students in our class here. Okay, we've got Zara, and we have Sapita. Can you stand up and just say hello? Okay, so you know who you are. Zara, Sapita, and Dorcas is here. Okay, who wants to start, folks? You want a card? Why don't you come on up here?
So thank you, Dr. Hanrahan, again for coming to speak with us. I was just wondering whether you just mentioned that in the future everyone will be working with data, and I was wondering whether you'd be able to comment on how you see the usage of visual analytics change and how you personally envision it will evolve in light of business innovations. Today we're seeing evidence of how personal visualizations can be used by the ordinary person with our devices and how data is becoming more prevalent in our lives. In business, we can see how the Internet of Things and big data in the cloud are coming together, and Gartner's predicting that half of the businesses in the world are going to be using what do they call it? There's predicting a disruption of advanced analytics and predictive algorithms, and I was just wondering how you see these innovations from an enterprise level translate into an ordinary user context where visualizations are a medium for everyone. And how you see how we might be able to analyze data on our own to share stories the same way that a doctor or teacher would, or how you might use big data to win your next Academy Award.
Thank you. Okay, well, there's probably a couple questions in there.
Yeah.
Let me see. So, well, I mean, actually, one comment about everybody using data. Actually, the biggest impediment to that right now is just organizations that don't want to give people access to data. You know, a lot of people, they sort of lock up the data and they protect the data, and second, they don't want people to use data to make decisions. I mean, like, you know, if you look at companies, I think one of the things that's happened is a lot of the most innovative companies have become very transparent with open data architectures inside the company, and the management encourages people to use data to answer a question. The other, maybe even more, I would say I would call it traditional, but a lot of companies never had that kind of mentality. They have all their data locked up in these big data warehouses, and nobody can get access to it unless you're in IT, and so on. So people just can't get access to it. And second, the CEO or whatever just doesn't care if people ever look at the data, right? They just know, you know, they aren't expected to come to the meetings with data. So I think in terms of, you know, the more widespread use of data in companies, it's going to be mostly about changing the way companies are run so they become more analytically driven and they give people in the company access to the data. So that's one of your questions. Yeah. You want another one, or you? Oh, the Oscar one. Actually, by the way, great book, if you haven't read it, is by Ed Catmull called Creativity, Inc. And he actually is fairly skeptical. I mean, you know, there's different uses of data. You know, there's sort of the traditional marketing uses, and the movie industry does a lot of things to try to make movies that are popular, right? And he's actually pretty skeptical in this book of those techniques because he doesn't think they lead to great movies. But I'll let you read that. I don't actually have any personal opinion on that. In the case of games, it has. You know, the thing about games is, which was really interesting if you followed the game companies using data, and the movie companies aren't nearly as far along as the game companies, is the producers would have some mental model of how people played the game, right? Like you do this first, and you do that first, and you get this reward, and you get this star, and whatever. And then they'd watch them play the game, and you got killed on the first thing that happened. You got killed, right? You know, so their mental model of what was happening was completely different than what people were experiencing. And I actually believe that could be the case in films as well. I'm actually doing some research where we're using eye tracking as people watch films because we think the films have been edited in very specific ways to control your attention, but you're actually finding out that people are looking at things that the director or the cinematographer aren't expecting, right? They're not being controlled in the way they expect. So it just seems like, you know, that's one of the things that just, as you hone your craft, like in the case of, I showed the example of the tables, I can sort of sometimes look at a visualization and see if it's going to be good at that particular task. You know, I've gotten better at that. I think the same thing would be true of a movie maker or a film or a game maker where they could use data to check whether what they think about their craft is actually true. Thank you. Yeah, thank you for the question. Yeah.
Hi. I want to start by thanking you for being here tonight and
Everybody's
for
so
your
curious
amazing talk. And just to recap, you started your talk with predictive models and why we need people for the ethical judgment. And I was wondering what you think about how predictive and machine learning should be able to help users in analyzing their data based on your understanding of human and user needs. And what do you envision the next generation of Tableau would be for machine learning?
Yeah, so that's a good question. And that's a great question, by the way. So, I mean, one of the big problems when you use machine learning and you start having the results interface with people is the way the machine did the calculation, the way people think about it are completely different. So, and you may have seen this if you've been following those convolutional neural nets. They've actually tried to start visualizing all the intermediate things. Like there's all these features and stuff that the convolutional neural networks are using that are sort of odd and not like, you know, the way we would think of analyzing an image. And this has come up a lot in like clustering algorithms. Another example is the way computers cluster things is often very different than the way people categorize things, and so on. So what happens is, you know, the computer will suddenly, if you probe it, why it's doing it, it's going to reason like it's from another planet, right, or another galaxy. It's going to start saying, well, by the way, you had all these clusters and categories in English, and I'm not using any of that stuff because I invented my own system. And so, and then they start talking, and it's very difficult. I think that comes up a lot. So that's, I think, one of the challenges is trying to maybe, when you guide these predictive models, maybe even teach them how to talk to people. Like if you're going to, like if they start asking you questions, maybe they should be able to answer in the language that you understand. And that seems like a big, an open problem on that. What was the second part of your question?
And what is going to be the next Tableau regarding machine learning?
Oh, yeah. Okay, actually, so one thing, I have another slide. I took this out, but this is sort of cool, actually. So it's a perfect question, man. I took this out because I knew I'd run out of time. But anyway, I would like to make an analytical assistant, okay? And this is from my favorite book on statistics by Mostello, Feinberg, and Rourke, which is an old book in the 60s. But it has this great quote in there, although we often hear that data speak for themselves, their voices can be soft and sly. We need statistics to help tell their story. So what statistics to me is about is when you're dealing with data, you can get tricked, right? Things could randomly happen, and you think they're causation or something like that, correlation, causation. So you have this hypothesis, you have this rigorous test. So I think the computer should just be in the background testing whether what you've seen is actually statistically valid. So for example, if I've made you these two bar charts, you just happen to want to make those and look at them, and then it could tell you, well, these differences are significant and those differences are not significant. I made this up. Sorry, my eye. And the reason why, because if you looked at the data underneath, one would have this really wide distribution. If you looked at the calculation and when you summarize the sum, one would have this wide distribution, the other one didn't. So it should just be there sort of covering for you, right? It should say like, by the way, we know that you can be tricked, right? And so you should just be checking, in behind my back and flagging things. Again, be careful. Remember my 3 rules. If you know you're being misled, tell the person they're misled. If you don't know it's okay, tell them it's okay. If you're not sure, just don't tell them anything. Let them go about their business. But I think that's actually a pretty interesting thing. And we actually do a fair amount in Tableau where we use machine learning stuff sort of under the hood in ways you wouldn't even know to just help you guide you to various things that just keep you out of trouble. We're just trying to keep you out of trouble. Another question?
Thank you so much for such a great talk. Actually, I was wondering that humans' intuition can be enough reliable in the area of visualization analytic, or there are other superpower out there we have not think of that, and we should think about them and use them to complete our analysis.
So you said our intuition is unreliable, right?
Humans' intuitions
could be unreliable. Or biased, right? Actually, I agree with that. And I think that's one of those things you have to teach people about is how they have biases. And that's an example of why you might want to use statistics is to prevent biases. But on the other hand, I think computers have biases too. It's like, they only collect certain data and they only run certain algorithms. And so they, in the same way as we're biased. And I like the idea that they might be biased in ways different than we're biased, right? Because, it's like that's what diversity is all about, right? Somebody is biased one way, another person is biased another way, the computer is biased a third way. That's great, We just need some way of forming some collective judgment about all the various points of view. So I think, so it doesn't bother me that computers are, biased or don't always work. It doesn't bother me that people are biased and don't always work. I just think that's sort of the way the world works. So we just have to learn how to deal with all the biases and limitations of all the different algorithms. I think that's the way to think about it.
So you think that method can complete the human's intuition and computation?
Yeah, well, except for the problem that the computer has to learn to communicate to people in terms that they understand, right? So right now, the computer is living in its own world, and we're living in our world, and we can't communicate except by saying, do this. So that's the challenge, I think, is having the, communicate. Because if two people are working on it, and I have one point of view and you have another point of view, we can still communicate. We still have the ability to communicate. Any other questions?
Yeah, so we have time for a couple more questions. Is there anybody in the audience that would like to ask? Please make your way to the mic. We've got 1, 2 coming up. Being very polite with each other. You go first, you go first. If you just say your name and then ask your question, that'd be great. Thanks.
My name's Jesse. I'm wondering, I got a question about questions. You had some questions in your PowerPoint, and I'm wondering how you think is the best way to kind of come up with these really good questions, because often what I find is that you have people who work with data, they know the data really well, but they don't know the subject matter that well or the business that well. And then you have people who know the subject matter or business really well, but they don't actually know the data that's available that they could even frame their questions with. So I'm wondering how you kind of bridge the gap between those two to kind of come up with really effective questions.
Yeah, no, that's a great question. By the way, that's probably the second thing I most teach people how to do is like ask the right question. Particularly like in research, I'm sure anybody in research knows that the key to research is asking the right question, right? And that I wish I had a simple formula for that. Unfortunately, I don't. I think there's some mechanisms and tricks you can do to try to help you ask the right question, right? Sometimes you just want to, like when I was in science, people were just super conservative. They were just sort of skeptical, right? If you're skeptical, you might ask a lot of questions, right? Like, oh, so-and-so did this experiment, but I just don't believe it, so could I come up with, is there another way to ask the question, another way to do the experiment, just because I'm skeptical, right? So, a lot of scientists are just a little skeptical, and a lot of people have discovered amazing things by just being skeptical. So I think that comes up in analysis, looking for outliers and unusual things. Like, Feynman has some great stuff about how he discovered various phenomena where he would look for sort of strange things, right? Look for things that, he couldn't explain, right? And ask questions about those things. So these are all fairly sophisticated things, but I don't think there's an easy, and also, some questions lead to big breakthroughs and some questions are just fairly straightforward. Lots of questions I find in businesses are actually very easy to state. Like that, I give the example of our dean. She didn't spend a lot of time thinking about that. Although it's sort of interesting. That's an interesting question. Like, why did she wonder? I mean, she obviously had a purpose in mind, right? Like, she wants to interact better with all the other departments outside the School of Engineering. So she had a motivation for asking that question. So part of asking good questions is to try to maybe do some good, right? She was trying to help our relationships with these other departments, and therefore she asked that question. So anyway, I don't know the answer to that, but if you're ever in my lab and we're talking as my grad student, all we're going to talk about is whether that's the right question. Can we come up with a better version of the question? How are we going to brainstorm, come up with some new questions? That's sort of my day, is like trying to figure out the right question.
Hello, my name is Matthew. My question is, earlier on in one of your slides, you mentioned that in the future, people, different domain experts in different areas will have more access to tools that will analyze their data to answer their questions. At that point, what do you think will be in shortage if these types of tools will be abundant?
I think the shortest will be to have clear analytical thinkers. I mean, the problem in analytical thinking is there's holes lots of times. I mean, we won't have all the data, and we won't have all the data and all the tools we need. So we're going to have to make some leaps of faith and so on. So I think it's going to be like how people, deal with all the unknowns. It's like, there's all these. The trickiness is there's all these unknowns. If you're doing analysis, there's all these unknowns, right? And so how are you going to make those unknowns known? And that's probably going to be what'll slow people down the most. And so figuring out how to solve for those unknowns is not easy to do. You might have to collect more data, you might have to collect data in a different way, you might have to invent some new analysis methods. So I think it's never quite I've mostly showed you very simple questions. If you let's say you're Steve Jobs and you say, where do I want to put the next Apple store? Just think of all the subtleties of that question. You know what I mean? Just if you really want to, we want to build up our brand in this part of the world, and we want to, let's want to make our sales go up. Just there's all these subtleties to that. So when doing analysis, actually, it's really interesting to read too the example of cigarettes cause cancer. That's a very humbling 50-year journey of analysis to finally get some legislation enacted there. So, people would say, a bunch of people did some really great analysis, and then people would punch holes in their analysis. And they had to get some more data and do some more analysis, and people would punch holes in their analysis. And they'd do some more analysis, people would punch holes. And the people were punching holes, maybe unfairly, but they were legitimate issues to raise, and since people wanted to make sure it went through some vetting process, it took a long time to actually sort of prove to the point where they would do legislation. So it'd be nicer if they would have did sooner, but still, that's a very typical process where there's missing data, there are holes in your argument. That takes a long time to fix all that stuff.
Thank you.
Hello, my name is Rod. I really hesitate to ask a cynical bit of question, but you were sort of paraphrasing Donald Rumsfeld's known unknowns and unknown unknowns, so
right.
I'll take that as permission. The famous quote, it's been attributed to both Thomas J. Watson Sr. and Louis B. Mayer about, I want an employee who will tell me exactly what he thinks, even if it costs him his job. And that some managers may take that approach to data as well. It'll be interesting, if your data analysis brings up news that I consider bad news, and then when there's bad news, heads will roll, maybe shoot the messenger first in the data analysis department. And that was more eloquently stated by Douglas Adams. I think it was in his Dirk Gently's Holistic Detective Agency novel about a decision support system where step one, you type in a decision you've made, and then the system goes away, finds all possible data that will support your decision and presents it in the way that is most supportive to the decision you typed in to begin with.
Right.
So, maybe it's academics who are chuckling. I think that's a comical idea. Out in industry, damn, that's the way things are, in my sad experience. So, do you think a solution might be something like the Hippocratic Oath for doctors, or these rules by which professional engineers can be thrown in jail if their bridge falls down, that there needs to be some sort of a formal ethical institution for data analytics, or is that going too far? Oh, and by the way, my cynical take on your dean's unanswerable question about what are the engineering students taking most often is that, say in the ISO, OSO higher levels, like there's a session and application layer presentation, that there'd be an 8th layer called the redaction layer, which makes sure that any unsalubrious data results can never make it up to the presentation to the user. So I'm, okay, that's my cynical question.
Okay, well, again, I think there were a couple in there, but I think, data analysis, actually, I gave a talk once called Systems of Thought. It's a sort of fun talk, but the point of that was that you want to apply different ways of thinking about problems in order to solve the problem. So data analysis is only one way, one component to solving a tricky problem, right? And, the data might give you some insight into how to solve the problem. It might not completely solve the problem for you. So whether you want to use data analysis, it's very rare, I think, that, except in the simplest cases, that data analysis by itself solves some complicated problem, some really complicated problem. It can solve simpler problems, but so you have to be able to weave it in there. And I don't think you can just always say, just because the data says this, that you should do it the way the data says. So I think people should be appropriately skeptical of it. And people will manipulate, obviously, rhetoric is a big issue in all this. Somebody has points, again, everybody will have a point of view, and no matter what it is, they're going to try to make what their point of view carry the weight. So that comes up with data, and that comes up with all forms of argumentation and presentation. I mean, I just think people just need to learn how to question these things and think them through and discuss them. And I think by having some transparency and having the process, and whether it's the data or the other ones, be open for discussion, then at least the totally bogus things I'd like to get rid of. Okay, and I do think that is often very good. Like, what happens is if you throw out the totally untrue stuff, that's often really helpful. So like if you think that, this is true, like those, like you have something like, that school teacher thinks this is true of all our students, and the data does not show that's at all true. And it just isn't supported at all. I think that is a lot of value to just throwing out these like completely bogus things. So, whether you've solved all the problems, but you can at least get people moving forward. So, I mean, these are good. I like these questions. I just don't know if they have simple answers. By the way, if I take a teacher course at Dallas, this is the kind of stuff we'll talk about. Like, how do you reason through this stuff? How do you know if your data is good enough? How are you going to have an organization that has good practices for using data in this decision, stuff like that.
This course you keep talking about, is it going to be a MOOC? Can we get online?
Not a MOOC.
Yeah, go ahead, next. We have time. We're running a little out of time here for questions. Thank you for taking the time to take all these questions. So these will be the last two.
Given long answers.
All right. Hi, Professor Hanrahan. Thank you for your awesome talk. I really like it. My name is Tsepeng. I'm a master's student in computer science in UBC, currently working with Tamara. So as I know, Tableau is building software on almost tabular data, which is typical structural data. But as we know, there are like semi-structural data or unstructured data like speech, text, image, or even more complicated, a mix of all kinds of data. Mm-hmm. So my question is, what do you think about the chances and challenges in visualizing these data for general public?
Yeah, so the way and there's a bunch of examples like graph data or visual data or text data. The way I always try to start on those problems, and I think about those, is how do people reason about that data? Like what questions do they ask, and what methodologies do they use, right? So like, for example, if you have graphs, there's a bunch of, like graphs, you might want to know about relationships between, things at a distance, or you might want to know about, things like centrality. But what I often just do is like start writing down the kinds of questions that you might ask and answer with that kind of data. And then particularly if it's well developed and somewhat formalized, there's a well developed methodology for it, then as a tool builder, you can try to make that easier for people to do and speed up the process. So the problem with some of these areas, or at least when I've tried to figure out what tools to build, is it's not really clear, what the question, like say text. I mean, a lot of the kinds of questions, like if I go talk to a historian and they're reading a bunch of novels, and I ask them, like, what are they trying to learn from those novels? Like, what questions do they want to know? They give me these really complex questions, like they want to know about this period in history or all these really hard things, which I don't even know you can answer quantitatively very well. And then when I go look at the people sort of doing text analytics, they're sometimes answering these really different kind of questions that, sometimes maybe aren't even that interesting. So I think so you have to work through. So if you have a well-defined methodology there, then you can build the tools, but if you don't. And so graphs are another good one. So anyway, that's the way I approach a problem, is figure out how the professionals try to use that data of those various different forms and what methodologies they use for analyzing it, and then you try to make it easier for them to do and faster.
Yes. My question, I guess, is following up the machine learning and Tableau question. With the new breakthroughs in machine learning, do you think the number is going to change if you assume again that 99% of the people still work on spreadsheet-like data? Do you think this number is going to change? And if it does, how is it going to change with respect of Tableau? In the sense that if you're leveraging right now with your data model and your operations, the relational 50 years of literature we have with machine learning, will it really change to something that is actually not Tableau at all?
Yeah, well, that's possible. I mean, I think, the problem would still be about, I think my original comment was just, what do the people do and why are they involved, okay? And I don't think machine learning, even if it gets better, is going to change that dynamic that much. What will probably happen is for problems where you don't need to have people involved, you'll be able to automate a lot of those. But where you have people involved and people's concerns involved, you will probably have only less improvement in those algorithms. So, I think, and I don't actually know the percentage. I wish I could predict. I do think I should say one other thing. A lot of the most complex decisions are also the ones we value the most, and we care about the most. So, because, again, movie recommendations or ad placement, that's cool and makes people a lot of money, but, the average person doesn't maybe care if Netflix doesn't always recommend great movies. But, the examples I gave were where people really care about these things. Then they're, so those things will still be super important to work on, is the things that people really care about and are really, hard to analyze. So.
Excellent, thank you. So we're going to leave the questions there. Once again, folks, can you please give our speaker Pat a hand? And just before everybody shoots off, and Pat, before you head off, we have a token of appreciation. So Dorcas here has something she'd like to present.
Thank you, Dr. Hanrahan, again for being here with us. It's been an honor, and I think as a student, this is a talking stick made by Jim Yelton of the Coast Salish.
Oh, cool.
And it's a symbol of democracy and speech, and it's crafted with stories, and we just wanted to show our appreciation and thank you. As a student in the Colloquium,
Cool.
it's just been a privilege to learn from you, so thank you for being here.
Thank you very much. Yeah, that's awesome.